Hello, this is Mr. Brain and this is Quick Now Tutorial. So, I want to quickly touch on the binary operation as the question. Alright? If you are writing down, this is one of the topics you are expected to prepare yourself on. And it is binary operation. So, I'm going to be taking this topic by solving questions actually. So, I'll be solving outline questions on the board and explaining the topic at the same time, okay? So, but the simple thing you must know is that binary operation is just, an operation that involves two terms, alright, one and the other, okay? So when you're having an operation in between, you're operating this against this. Then there will be, a function or a formula that you must follow in order to get your output. Let me give you an example. If I'm to operate 2 plus 1, you already know what to do. You're going to count 1, 2 plus another one. That's 3, right? So this is a binary operation, okay? Alright? But if we have a more comprehensive or, another operation that will represent all these operations. For instance, if I have 2 operation 3 and it's giving me 2 plus 3, alright, minus 2 times 3. Now, this operation includes both the plus and the minus, then the multiplication, alright? So, we can simply say A operation B, this operation is called asterisk. A operation B is simply A plus B minus A times B. Do you understand? So, this whole operation represents everything we are doing here. I don't need to understand. This is asterisk. And so on and so forth. So, this is what we need. When you have A, that's your 2, and you can see your 2 and 2 times 2. You understand that, right? Okay, let's solve the question on the board. While we are solving these questions on the board, you will end up understanding some of the operations under binary operation. So, the first question is, if the binary operation is defined by m asterisk n equal to m times n, that is mn plus m plus n, for any real number, m and n, find the identity element under this operation. An identity element, that's what we're looking for. When you say identity element, it means that element that will not change the result once operated on. So, if A operated by identity element E, my answer will still be A. It's not going to change the output. And when you multiply 2 times 1, the answer is 2. So for this operation multiplication, the identity element is what? 1. 3 times 1 will still give you what? 3. So the identity element for multiplication is what? 1. Now for addition, the identity element is 0. 2 plus 0 will give you what? 2. And 3 plus 0 will give you what? 3. The identity element for addition is 0. Alright, so now, so with this, A operation E will give you A, where what? E is the what? Identity what? Element. Now, another word for identity element is neutral element. Or neutral what? Element. Okay? Alright, so let's do this question now. So, we are looking for what? If the binary operation is this, alright? Find the identity element. We are looking for the neutral element, okay? So let's bring the operation here. M operation n equal to mn plus m plus n. So let E be what? Identity element. Now, what is that element that when we operate, we will not have a change, the result will still remain the same. Alright, so let's say M operation N, E, we give me what? M, this place now, E has replaced the position of M, so we're going to put E here. E plus M plus what? E. Alright, it has replaced the position of E now. So what do we have now? So this expression must give you what? M. Remember, A operation E must give you A. So this expression must give you M. Then we'll now make E the subject of what? Formula. You understand? We make E the subject of the formula. That is how to get what? The neutral element. So what do we have now? Factorize E here now. So we have M plus E equal to M minus M. This M is going to the other side, right? We have one M here, and this other M is coming here. So M minus M. So M E plus E is equal to what? 0, right? Factorize. So E open bracket M plus 1 equal to 0. If I go side by M plus 1, so E equal to 0 over M plus 1, which is what? 0. The identity element for the operation under the set of what? Real numbers, right? Under the set of real numbers is 0, alright? So now let's solve the next question. The next question, please. Alright? Now to solve the next question, let's go. It's getting interesting. So we have a binary operation after it is defined on the set of all positive integers by A after a B equal to what? AB for all positive integers AB. Which of the following properties does not hold? Now this is AB. A operation B is what? AB. Which of the following property does not hold? Let's see. Alright, the first one, closure. Now the closure property means after operating, you are still going to get a result that is part of the set. So what set are we looking at? Now this is a what? A set of all positive integers. Alright? So the two elements that will be operated must be positive integers. And the result must be what? A positive integer. Will that occur? Yes. If we have 2 times 2, okay, let's say 2 times 3, that will be 6. For every positive number that we put to operate under this set of operation, we're going to get a positive integer. So now, it's a closure property. Do you understand that? So multiplication is what? Closed under this operation. Not every operation is closed, alright? Not every operation is closed. Now, let's move to the next one. Associative. Yes, multiplication is associative. For instance, I have A, right? Okay. Now, if I have A operation B, right? Operation C, right? I'm still gonna get what? It's still gonna give me if A operation what? B operation C is still gonna give me the same answer as what? A operation B. Can you see that? Then operation C. This whole thing will give me the same answer. How do I know? 3 times 4 times 5 is still the same as 3 times 4 times 5. No matter how I put the bracket, I'm still going to get the same answer. Because even the bracket itself means multiplication, alright? So this is associative. Alright? It is what? Associative, right? So this one is part of it. Now the next one, identity. Do we have identity elements under multiplication? Yes, we do. Alright? Let's find our identity element. Remember, identity element is the element that when you operate, it's not going to take the output. So we have A operation, identity element or neutral element. We are still going to get A. Alright, so let's do that. A times B equal to A. So divide both sides by E. Remember, we're looking for E. So if you divide both sides by E, it means that E is 1. I told you earlier that 1 is what? The neutral element for multiplication. Alright, when you are multiplying, 1 is the neutral element. Alright, so identity element, it has it. Alright, so inverse doesn't work for inverse. I think this is most probably the answer for this question. Okay? Now, the next question. Let's solve the next question. Now, the next question says, if A operation B equal to positive root AB, evaluate this. So, A operation B is positive root AB. So, let's evaluate 2 asterisk 12 asterisk what? 27. Okay? Under this rule, remember the positive one. You have plus or minus, but you are looking for just the positive, alright? So now, let's go for the bracket test. 12 operation 27. That's the best thing to do. You simplify the bracket so that you don't have a single result. Then you can now operate with the one outside too. Okay, so what do you have? Positive what? 12 times 27. Alright, so let's express this. So you know this is 4 times 3. And this is what? This one is what? 9 times 3. So 3 times 3, that's 9. So at the end of the day, I have to what? 4 times 9 times 9. I hope you understand that. So 4 times 9 times 9 is just now square root of 4, 2, square root of 9, 3, square root of 9, and 3. And that, this is just a way of, you know, that's my own method of making it very simple. You can try to multiply this like this and find the positive square root. But this will also go and with a factor, alright? So 2 times 2, now this is times 3, 18. So my answer is 18. And the correct option is what? Wow. Okay, we are still going to continue our operation, right? We are still going to continue our operation. Alright, we're supposed to continue. The answer does not end at 18 because remember, we're still going to operate 2, right? So let's do. So 2 operation 18. What would that give us? Positive 2 times 18. That would be what? Now you can break it down just like I did this first one. So you have 2 times 9 times 2. Which is simply what? 2 times 2, 4, 4 times 9, and that will give you what? Square root of 4, 2, square root of 9, 3, that is 6. The answer is 6. So the correct answer is what? Option 6. Okay, let's solve the next one. The next question. The next question is, if m operator n, alright, equal to m over n minus n over m, for m n element of A, evaluate minus 3 operation 4. So the operation m operation n equal to what? M over n minus n over n. Alright, this is just a pattern on how you should do the operation. Okay? You just plug in the first number here, then the second number there, minus second minus over first. Okay, so now when we have minus 3 operation 4, that will give you what? Minus 3 over 4 minus what? 4 over minus 3. Okay, so what we have, this is still like 3 over 4. Now this minus is multiplied by this minus and you have plus 4 over what? 3. Now how do you solve this? Just like the LCM. LCM is 12. Alright, 3 times minus 3, that's minus 9. 4 times 4, 16. So what do you have? Minus 9 plus 4, that should be 5. So 5 over 12 is the answer. So what option is correct? The correct answer is what? The correct answer is, let's go for, okay, you can see the answer is not really there. This is our answer. The answer is not really there. Okay? Alright, so let's go to the next question. Number 5. Alright, you can see that. Number 5. Number 5, the last one. It says an operation as stated is defined on the set of real numbers. Real numbers again. Alright? By A as there is B is what? A plus B plus 1. If the identity element is what? Minus 1. Find the inverse of the element 2. Alright, we are looking for the inverse. Real number, okay? Real number. So A operation B is what? A plus B plus 1. And we are looking for inverse of 2. Inverse of 2. Inverse of element what? Element 2. How do you get inverse under binary operation? Now, watch. To get inverse under binary operation is quite simple and very easy. All you need to know is that if A minus 1 is inverse, inverse of A, alright, under binary operation, A operation inverse will give me identity element. A operation inverse will give me what? The identity element. Do you understand? That is how to get identity element under any set of what? Rule or operation. Under binary operation. Are you with me now? So let's go. So we are looking for inverse of 2. First of all, what is our identity element? Our identity element under this operation is minus 1. Right? We have minus 1. So E is what? Minus 1. So let inverse of 2 be x. Alright? So 2 operation x equal to minus 1. Now, following this outline principle, 2 operation x equal to minus 1. Remember, x is our inverse. Okay? So, what is the operation? Look at the operation. So, let's do 2 plus x plus 1 is equal to minus 1. So, that will be what? X equal to minus 1, minus 2, then minus 1. When this moves to that side, and this other one moves to that side, minus 2, minus 1. Alright? So, x is what? Minus 4. So, the inverse of 2, inverse of what? Of 2 is equal to is what? Minus 4. Under what? Under the operation what? Asterisk. Under the operation asterisk. Alright? Remember, this is how we solve this. Remember to subscribe and share this video to your friends that need this. Alright? Binary operation and thank you.